Okay, in this video, I'm going to demonstrate how to run a confirmatory factor analysis based on data from this article right here. It was found at the Plus One website. The article is Discussed Assessment, Factorial Structure, and Psychometric Properties of the French version of the Discussed Propension and Sensibility Scale, revised version 12. And basically, this site it contains open source articles, and oftentimes it contains supporting information. And if you go to that, you'll oftentimes see that they'll have the raw data. So this is in an Excel file. And what I did was I imported it into SPSS, and so now I can show you how to run a CFA on this data using the AMOS program. So that's the basic idea. So the basic paper that you see, this is it right here. So again, if you go to that site, you can download the paper. And in the paper, they actually run a CFA on the data using the R program. And they also utilize robust measures or robust estimation techniques because of problems with non-normality for the measures. In this demonstration, we're not going to actually focus in on the issue of non-normality. We're just going to basically generate a few models just to demonstrate how to actually create models using the AMOS program. So I will say that if you get the article and read through, you can see there's a lot of description about what the authors did. And again, that they started out by kind of talking about issues of skewness and kurtosis, and they actually discuss problems with normality right here, and that's why they ended up using the robust estimation approaches. But once again, we're not doing that for this particular demonstration. It's just basically about drawing out the models and running it without making any kind of accommodation for that. So their factor analysis, they start off with a two-factor model, and if you scroll down, you'll see in Table 1, you can see the items that are associated with the two proposed factors. So you can see that one factor is discussed propensity, and then you have discussed sensibility. And the items are actually, you can see both the French version and English versions. And then over here, you've got basically Model 1 and Model 2, and you have the loadings for those two models. So what we're going to do is we're going to start off with the two-factor model. And then one of the things that they noted is that they felt after they ran the model incorporating all 12 items, one item, which was item 11, did not reach their cutoff anymore. So they ended up rerunning the analysis, and they ended up actually not including two items. That would be items 11 and items 12. So we're just going to run these different models in AMOS. So here we have a basic kind of drawing space, if you will. So the first thing, we're going to import the data. So I've actually already done it, but I'll just go ahead and show you again. You just basically find your file and then open it up. And so now you can see we have 281 participants who had responded to this particular scale. And next thing we're going to do is we're going to draw out the model. So I'm going to go up here, click Draw Observed Variables, and I'm just going to draw out, there are actually 6 items per factor. So I'm just going to draw out one item right here, and I could actually draw this out, but I can actually make this a little cleaner and a little faster using a couple of other techniques. So I'm going to show you how to do this. So the next thing, I'm going to go ahead and click on this button right here to add a unique variable to an existing variable. So I'm going to click right here, and if you click several times around, you'll see it just goes around. So I'm going to stop right there. And next, I am going to click on Select All Images, and then go to the copy machine where it says Duplicate Objects. And now I can actually drag down. So instead of having to draw every single box and every single error term, and then every arrow with a fixed loading of 1, I can just kind of use a little copier here and drag. So this makes things go a lot quicker. So now we have 1, 2, 3, 4, 5, 6 items associated with the first factor. And then I'm also going to drag this over here for the second one. So I'm going to move this over here. So there's 1, 2, 3, 4, 5, and 6. And then I will click off of this. Now you'll notice that and then click off the little copy machine as well. So you'll notice that our little error terms are on the left side, and actually I want to put them on the right side. So I'm going to go up here to this add unique variable again, and when I click on that and move over here, I can move this around. So I can do this for each of these. So now we have a little bit more space to work with to draw our factors. So I'm going to click off of this and go to the oval, and then I'm just going to draw out, that's going to be factor 1, and I'll use the little copy machine and draw factor 2. The copy machine is really neat because it allows you to kind of maintain, you're not drawing objects that are differently sized or anything of that nature. So now I've got my 2 factors. The next thing I'm going to do is I'm going to go here to list variables and data set. And in the presentation, basically they have the following items loading onto propensity. So they basically have item 1, they have item 4, they've got item 5, 6, and then 8 and 10 loading onto propensity. And then they have the remaining items loading onto sensitivity. So there's 2, item 3 right here. They've got item 7 right here, 9, and then 11 and 12. So there's 11, and then there's 12 right here. So next we need to label our factors and our error terms. So we'll start off with the factors. So I'm going to right click here, go to Object Properties, go to Text, and we're going to call this propensity. And then I can click over here and I can call this sensitivity. All right, so now let's label our error terms. So I'm just going to call this E1. We'll do right here, we'll say E2, E3, oops. We have E4, E5, E6, E7, E8, E9, E10, E11, and E12 right here. So next we want to draw our arrows to denote factor loading. So I'm going to draw a single-headed arrow from the latent variable to the indicator variable. So these right here are all, we have propensity being drawn to each of these, and we have sensitivity with arrows drawn to each of these indicator variables right here. Okay, and then next up, what we want to do is we want to add a covariance between propensity and sensitivity. So we'll use a double-headed arrow there. So I'm going to click off of that. Now, the last thing we need to do is we need to make sure that we set a measurement scale for our latent variables. So pretty much one of the most common ways is to basically fix a factor loading to 1. So we're going to set the scale of the latent variable in relation to one of the indicator variables. So I'm just going to go ahead and go up here, and for propensity, I'm going to right click on this arrow, click on Object Properties, go to Parameters, and I will type in 1. So now you see the 1 appear. I'll do the same thing over here. Actually, since the box is open, I can just click over here and type 1, and there you go. So next we'll go to Analysis Properties. There's no missing data in this data set, so I don't really need to click on Estimate Means and Intercepts. If there was missing data, then I would need to click on that if I was going to run the analysis, or else I would end up with an error message. So we'll click on Output, and we've got standardized estimates. Actually, I've already clicked that. Squared multiple correlations clicked. So, and then I'm just going to stick with those for the time being. So now we'll click on Close, and I'm going to save this. So I'm going to save as, and it's basically being saved as Model 1. I'm just going to save over the old file, and we'll run the analysis. So I'll click on Calculate Estimates. So when I click this box here, we have our unstandardized, and then go here. These are the unstandardized estimates. This is the covariance between the two variables. There's our factor loading fixed at 1 here, factor loading fixed at 1 here, and our unstandardized factor loadings that were freely estimated. Over here we have our error variances that have been estimated as well. If I click on standardized estimates, this right here is the correlation between the two factors, and then we have standardized factor loadings that are presented. And then these values right here, the 0.35, 0.45, and so forth, these are basically R-squared values reflecting proportion of variation in the manifest variables accounted for by their respective factors. So I'll click on View Text, and we'll start off with the model fit. And so you can see right here we have the chi-square goodness of fit test. It is statistically significant, so that is an indicator of poor fit. We don't typically rely solely on the chi-square goodness of fit test just because it is so heavily impacted by sample size, and it's very easy for this test to be significant when you're dealing with SEM because it is a large sample technique. We have GFI and AGFI. Both of these are above 0.90, which are acceptable levels. CFI is above 0.90, which is acceptable. Generally, you're still looking for about 0.95 or above, but these are acceptable levels. TLI is a whisper low relative to that, kind of acceptable level, if you will. If we look at RMSEA, the value is 0.06. This would be acceptable as well. As we look at the estimates right here, we scroll, we can see that we have the unstandardized factor loadings that are given right here. We have our two loadings that are fixed at 1, so there's no significance test associated with those, but we have significance tests associated with all the remaining loadings, and all of them are statistically significant in this model. When we scroll down, we have the standardized path coefficients that are given here. Scroll down a little bit further, we have the covariance between our two factors. It's statistically significant, and then the correlation between them is 0.556, so a pretty good size correlation. Then as we look down, we have our squared multiple correlations, and so again, these are those values that we saw over here. So if we kind of look at DPSSR underscore 1, you can see right here it's 0.346. Up here it's rounded off at 0.35. The next one, number 4, is 0.45 right there, and down here you can see it's 0.446. So it's rounded off to 2 decimal places in our model, our diagram. So next, what we're going to do is we are going to basically rerun our analysis, but the next the next analysis that they basically did, they took out item 12, or excuse me, item 11. And again, they basically said, viewed that they perceived that this item was not good to include, so they took it out. So what we're going to do now is just simply remove that item. So I'm going to remove item 11, and so this is kind of a next model. This would be kind of a model 1A, if you will. So I'm just going to save this as, and we'll just call this model 1A, and click on save, and kind of run this model right here. And so now what we see when we're looking at our fit, you can see it's still statistically significant, the chi-square goodness of fit test. Now we see the CFI bump up, TLI bump up. These are looking a lot better right here. The GFI and AGFI are looking better as well. When we scroll down to the RMSEA, it's also looking pretty good as well. So clearly we have an improvement in model fit after eliminating item 11. We look under estimates, we can see again, all of our factor loadings, unstandardized factor loadings, are statistically significant. There's our standardized factor loadings as well. We do see that item 12 has a particularly low factor loading relative to all the others. If we scroll down and look at the squared multiple correlations, you can see that that basically the sensitivity factor only accounts for about 4% of the variation in that. So that is not a great item right there, and that's pretty much what the authors kind of indicated too. So they ended up deciding to run the analysis with 6 items on the first factor and then 4 items on the second. So in this case, let's do this. Now in this case, we're going to click on the little X right here and delete this item as well. So that leaves us then with 6 on one and 4 on the other. And what we'll do is we'll go and save this as kind of model 2, if you will. So we'll save this as their model 2, and we'll rerun the analysis now. And so now when we look at our output model fit, you can see chi-square test is still significant, but it's it's getting closer to kind of non-significance. You see a little bit of improvement on CFI and TLI, GFI and AGFI. All of these are indicating pretty very good fit. Our MSEA is also lower as well as a result of deleting that item. So in this particular case, we definitely have an improvement in fit as a result of basically deleting items 11 and 12. So that's pretty much what they did. If you want to, if you end up deciding to run this and then comparing your results against the author's results, just keep in mind that again they utilized CFA with basically robust standard errors and robust fit statistics. So we didn't do this in this case, so there will be some differences as a result. One final demonstration is just, I thought I would just test a one-factor model to see how well it stacks up against this two-factor model. So what I'm going to do in this case is I'm just going to go back and open up that first model and eliminate one of the factors. So I'm actually just going to eliminate this one right here, and I'll just use my little move objects over here and kind of clean this up just a bit right here. And then I'm going to add loadings on the other side. So we're just basically testing a one-factor model to see how this fits. And this is just for a demonstration. This is not actually in the paper, as I recall. So now what I'll do is I'm just going to save this as, and I'm just going to call this one-factor model 1A. And in this case, we'll run the analysis. And when we look at our model fit, you can see it's statistically significant. The chi-square goodness of fit is statistically significant. GFI, AGFI are low. CFI and TLI are really pretty awful. And the RMSEA is above acceptable levels. So, you can see right here that the one-factor model fit the data very poorly. When we look at the estimates right here, you can see that all the loadings were still statistically significant. But again, the overall fit was poor. You will notice that there is only one loading in this particular figure with a fixed that's fixed at 1, and that's the propensity going to item 1. So just remember that when we had the two factors, we had to set the measurement scale of each of those factors. But in this case, because we only have one factor, we've only set that one loading.